Hello guys, today I am going to show you that how you can find the target in the sorted matrix. Target in the sorted matrix through staircase method. Staircase method. Okay, so here I go. First of all, write the basic boilerplate, which is hashtag include IOString. Why do we? There's always a reason before including anything in the coding, because we don't want anything rubbish to be written in the coding, right? So every line has a meaning about it. Like hashtag include IOString, which we are using. So it's a header file which like tells that there's something exists called cout or cin, and then we include using namespace std, which tells that cout cin exists, but what is the function of cout or cin is written over in this header file. Okay, so and if you would have not included using namespace std, then what you would have to do, that wherever you would have be writing so what you would have to do, that you would have to include like this. Okay, so instead of including like this everywhere, you can directly write using namespace std. Now int main return 0. Now suppose I'm creating a matrix of 3 rows and suppose 4 columns. Okay, so altogether how many elements would be there inside? 12 elements. Let's take the 12 element, like 1 2 3 4 5 6 7 8 9 10 11 12. Okay, I took the 12 elements. Now what I have to do, that in the when you have to search anything in the sorted matrix. Okay, so sorted basically means that rows and columns both are sorted. And you would remember from the past, like binary search is very important for this question, and in the past we have discussed about the binary search, that when you have to find when you have to find any targeted element from array or vector, then what you would have to do, that instead of searching the entire array, if the array is sorted either in ascending or in descending order, you just check it out. Check it out in the sense like, why to traverse whole array? You just check it out, that take the middle element and just check it, that whether that middle element is greater than your target or your target is greater than middle element, and accordingly you travel half of the array and you will get the answer. Okay, so the same thing is applied for this method also. For searching in the sorted matrix, you should always look for 3 methods. Okay, first one is the brute force, which after seeing the question, the first thing which comes inside your mind is the brute force approach. For the sorted matrix also, the brute force approach would come inside your mind firstly, like for I equals to 0, it will go to the greater than n I plus plus, then we will, for number of rows, for number of columns, we will take j element and we will go from 0 to n, and each time we will increase it and we will traverse the next row element in this manner, and each column would be covered from j. So we do in this manner. Okay, now I have to explain you regarding after so the brute force you saw, that go to every element and just check it. So in that case, what will happen, that your time complexity will be very much high. So what is time complexity? It's the maximum time which is required by an algorithm to complete. So in that case, the time complexity will be very much high. So in order to reduce the time complexity, you just, after doing the brute force on your copy, you just see the question, see the solution which you have written, and just think that is there any better approach which I can go for. Then you will realize that binary search is the approach. Like either we can say that row is sorted or column is sorted, or accordingly what we will do, that we will check the element inside the row or inside the column. Second approach, you can do this, but just give a stress inside your mind, that is this the only most better approach to do this question. Like when in the question it is saying that the row and the column both are sorted, so I'm not taking the help of both the things, right? In the better approach, what I'm doing, that I'm either taking the help of the sorted row or the sorted column, but I'm not taking the help of the like both rows and columns sorted, so something different approach should be there so that even the most optimized answer can be given. So for that reason, you will go to the staircase method, which is for the most optimized algorithm for this question. So in the staircase method, what happens that, see, when you will see the element, how it would be visible to you, it would be visible like this, 1, 2, 3, okay, and it would be then 4, 5, 6, 7, 8, 9. So inside the memory, the elements would arrange in this manner. I have taken, sorry, the column is, no, 3 rows, 4 columns are there. I'm so sorry. So I have to include one more element, like 1, 2, 3, 4. Then it will be 5, 6, 7, 8. Then it will be 9, 10, 11, 12. Okay. So basically the elements are arranged in this order. Now, it should be clear to you because it's very important for you to understand this algorithm. Nine, 10, 11, 12. Okay, so inside the memory it would be arranged in this manner. Now see over here that when we take this row, which is the 0th row and the 0th column, so if it is saying that the matrix is sorted, so is there any approach which you could think of, like I should go for, because after 1 here also it would be in the increasing order, right? Here also it would be in the increasing order only. Wait a second. So here also it would be in the increasing order only after 1 from in the row side. In the column side also it is in the increasing order. So now, like, you would be visualizing the things that here it is not giving any kind of hint, right? There's no hint over here. Now you will go to this element 4. Now what I mean to say over here, suppose your target is 4, okay, and you know that 4 is greater than 1. So should I go to the row side elements or should I go to the column side element? Because both side it is increasing only. You are not getting the hint that what you should do further with this. So now what you will do instead, that you will go to this element, which is 0th row and the column number is 3rd. Okay, now you will go to this element and suppose your target is now 9. Okay, now you will check that whether I should go, my target is 9, whether I should go left side or downwards. So what you will realize that in the left side, what will happen, that the elements are arranged in the, like, 4 is the maximum element. After sorting, the 4 is the maximum element, largest element, I mean. So 4 is the largest element. So it would say like I'm the greatest element over here in this row. So why you are checking on the left side of mine? Don't check. There's no use of checking the element on the left side of mine because I'm the largest inside this row. You could check downward. Okay. So what if this said that you check it downward? So now we move row plus 1. Okay, from here what we did over here, that here the row was 0. Now we move to row plus 1. Now we move to the first row. Now as the target is 9, right? So what will happen over here, that now 8 would say that 8 would say, see, I am here largest in the second row. There's no need to check on the left side of mine. Better go in the downward side of mine. You would find the element there instead. Don't waste the time over searching on the left side of mine. So now it would again give the suggestion to move towards downward. Now you will come to 12. Okay. Now after coming to 12, when you will see 9. Okay. So 12 would say, listen, I'm greatest over here and you are searching for 9. You just go on the left side of mine. So what will happen, that the element will, now we will move to the left side of this. So here we are moving column. So here we will, from column 3, we are moving to column 2. Now column 2, after comparing from column 2, column 2 will say you are searching for the element smaller than me, right? You just check it on the left side of mine. So here we again moved towards 10. But listen, the approach which I am discussing over here is right, but it would work in the staircase method. Like when I checked from 4, okay, so when I checked from 4, it would say suggest to move downward. We moved over here 8, right? And after moving towards 8, here 8 is the largest. After 1, 2, 3, 4, 8 is the largest, right? So we will check, suppose the target is 9. So we are moving over here. Now we will move on the left side. Now again we will check about 10. Now again, and on the left side we are going to check. Then we will get 9. So let me write the code. It would become more clear to you. Let's comment it out for a few seconds. Okay. Now let me write the code. So matrix I have taken is this. Now while, first of all I am taking int I equals to 0. Okay. For the row I am taking I, or let us take m or n because that is more familiar to you. Otherwise you could take anything. There's nothing such kind of restriction that you have to take m or n. Anything you can take. So I am taking int m equals to 0. Okay. And int n I am taking, what I will take int n, I will take the element smaller, means this side element, 0th row, 4th element. So I will take 4 minus 1, which is 3. Now I will apply while loop. While loop will say that m will be, you have to move till that time till m would be greater than or equals to, smaller than or equals to 3, and so that the entire row can be covered. I'm taking this condition so that the entire row can be covered from m, and n, which is the third, which is standing for column. So n should be smaller than or equals to 0. Till that time I have to move inside this while loop. Okay, so I have created a while loop over here. Now I am going to create a for loop. For, so what I am going to do, that int I equals to, so int I over here is going to be, so why are you creating over here for loop? There's no need to create for loop. I'm so sorry. If suppose I'm going to directly give if condition over here, if array of m, first of all I will check that element only, matrix I have taken, if matrix of m or n, okay, when it would be equals to the target element. Suppose the target element is over here, int target, I'm giving it as 11. Okay, suppose if m equals to target element, then you have to see out the index element is, or you could simply, instead of like as we are just practicing, instead of writing this much, you could simply see out m and n with some space, and then you will see out n. Okay, now else if, so what will be the else if condition? Now the target will be either, now the target will be greater than matrix of M or N. If the target is going to be greater than matrix of M or N, so when the target is going to be greater than this, in the binary search also used to do this, na? Comparing it every time. Like if mid equals to key, if mid is smaller than key, array of mid is smaller than key, then you were changing it accordingly. So similarly here also I'm doing that. If my target would be greater than matrix of M or N, then I'll move to the downward side of it, because on the left side the element is greatest, this 4 is greatest. Now when I will see that my target is greater than this, I will move towards the downside. So I will change the row element. So the row I will do M equals to M plus 1. M plus 1. Now the third last condition would be else condition, right? So else you would simply, here no need to write the condition, because you know that if the target is greater, in this case now the target would be smaller than this element. So when the your target is going to be smaller than this, you need to shift towards the left side. So for shifting towards the left side, you need to change the column, right? So for changing the column, what you will do, n equals to n minus 1. Okay, now let's run this code and check it once. Why it did not printed? Let's go through. I have written it to cout M or N. My target over here, what the target I have given? 11th. I have given the target also. Okay. See what I did, mistake of mine over here is, now when one more thing, when you do not get any element, so you should return over here, return -1, and after doing cout of this, you just return M comma N. Okay, now let's run this code once again. Why the element is not getting printed over here? M I have started from 0, N I have started from 3rd. M is going to be greater than or equals to 3. Shit, man. M should be greater than or equals to 2. Because I have started from 0, and how many rows are there? 3 rows are there. So 0 first, second. And if you would have written 3, then you should have not included equals to. And N should be greater than or equals to 0. This one is correct. Matrix of M or N if equals to target, then you have to return it over here. Else if it is going to be greater, when the target is greater, then you have to move towards downward, which is M equals to M plus 1. Else you need to do N equals to N minus 1. Equals to N minus 1. So now let's run the code again over here. Why the element is not getting printed over here? see out M or N? It's so true. I have to see out the index. If else case I have included over here. While loop I'm applying. But why it is not getting printed? So guys, here one error which I am able to find over here after dry running and all, everything is correct over here. Just if I am writing return value in this manner, no? So what does it means that you are returning one of the value, which is n. You are not returning both the values, both the indices you are not returning. So for returning both the indices, you need to just put it in the curly braces, and then you have to do return m and n. Okay, now what the error it is having over here? Expected a comma, so I'm giving the comma. Wait, I will solve that issue, but before that I need to just check that why it is not getting printed over here. Everything is correct over here. I have dry run it completely, but why it is not giving out this value, I'm not understanding that. Int m equals to 0, m and c out m, c out n. It won't make any difference, I know, but still, instead of searching and just doing this, let's run this code. It will give a huge error. Let's see what it is telling. Cannot convert brace and close initializer list to int and return. Do we have to give this bracket or what? Let me see. Yeah, okay. So we have to give in this bracket, but still the element is not getting printed. I have to print this element over here. Okay, fine. So one more error is over here. If you could find, please tell. Let me tell you what kind of error is there. I'm also in my learning phase only. Some error happens with me, guys. Here n greater than or equals to 0 if I have written, and the n value I'm taking 4. So is it ever possible, n values 4, yeah. Is it ever possible that 4 would be smaller than or equals to 0? Never. It is just getting reduced. So it would be n greater than or equals to 0. How could I do such mistake? So it would be n greater than or equal to 0. It's such a minor error. It means that it never entered in this condition, and when it never got entered, so how am I expecting that it would ever print the element? So first, before printing, it has to go inside this while loop, right? And I have given the wrong condition only over here, that I have not written greater than, means I have done opposite. Okay, now let's run the code. See, now it got printed. Second row, second column. Just check it. Where is 11? It is in the second row. It is in the second column. Okay, and you know how much path it covered? When you will dry run, you will realize I have dry run it right now. 4, 8, 12, 11. After just moving this path, which is 4, 8, 12, 11, it reached over here. So it covered a very short path. So this is the most optimized approach for finding the element inside any sorted matrix. I hope this would have been clear to you. And don't repeat the mistake, guys, which I am repeating. These are the horrible, reckless mistakes. Never repeat it. I'm so sorry for, but still. Now see. So this is suppose now I'm taking the target. Suppose now the target I'm taking is 12th. 12. Okay, let's run the code. Second row, third column. Check it. It's in the second row. It's in the third column. It's so simple. See what I did. That first of all, I created the array. After creating the array, I created an target m, which is storing the 0th, means it is storing the row. Basically what we say, that m cross n matrix I'm taking, right? So here m is 0, which is standing for row, n is standing for column. Now what will happen, that now I want that, see what I want, that this entire row and column needs to be covered up, right? So for covering this entire row and column, I have to give the condition accordingly. And I never started from here, or I never started from here, because the elements would be smaller in both the case. It is not giving any kind of clue that where I should go, whether I should go the row wise or I should go column wise, or means it is not giving you any clue. So I took 4 over here as the element, and in the next step what I did, see, this time I took this element, right? You you just do one question as a homework. You do searching the elements from the here. After searching the elements, m greater than or equals to 2, n greater than equals to 0, I did, because m is second two rows and n is greater than or equals to 0, which is, it's obvious, because n I have taken it over here. In the case what will happen, you will take m as 3 and n you are going to take as 0. Okay, so the whatever the conditions you have applied over here, just need to reverse it. That's it. Because here what will happen, that you are going to take m as 3 and n as 0. So you will do that when target is greater than, or means when the target is greater than this. So when the target is greater, you are going to search in this path. So for searching this path, you need to do n equals to n plus 1. And when the target would be smaller than this, then you would go above the, like you will go above, right? In the upper rows you will go. So for that you will, what you do, that m equals to m minus 1, you will just reverse the case. And here in the and condition, what you will do, that m greater than or equals to 2 you have written over here, and n greater than or equals to 0. So here it would be n greater than or equals to 2. M greater than or equals means greater than equals to 0, and n would be greater than equals to whatever the number of rows is there. Okay, and now after every time here matrix m n, which is for this element, it is checking that is it equal to target? No. So target is greater, yes. 11 the target is this time 12. Is target greater? Yeah. Move it downward. I came to 8. Now at 8 will say that I am largest over here. If your target is greater, move to the next row. So now it will move to 12. So 12 would say I am the only target you are searching for. Just return me. So how much did you cover? Only 4, 8, right? 2 paths you have covered. So this is basically the staircase method. I hope it would have been clear to you, and the mistakes which I have done, learn from it. These are reckless mistakes. Don't repeat it, and all power is within you. You can do anything. Just have the confidence that you can achieve anything. So this was all for today. Thank you, and keep learning.